Hi folks, we're going to take a look at page 564, number 8. So they're asking us to find the equation of the normal to this curve at the point 1, -1. Okay, so just recall that a normal line is just a line that's perpendicular to the tangent to the curve at that point. Okay, so that means in order to find the slope of this normal line, I just have to find the slope of the tangent at that point and then take the negative reciprocal. All right, so let me start by finding the derivative. Now, this is one of these instances where I actually could solve for y and then find the derivative using traditional methods, but I'm just going to use implicit differentiation. I think that'll be quite a bit easier. All right, so let's take the derivative of the left-hand side. So again, remember, I'm taking the derivative with respect to x, so I need to use a chain rule. So on the left-hand side, I'm going to have 2y prime. And then on the right-hand side, well, I have to use the quotient rule here. So derivative of the numerator is 3x squared times the denominator function, 2 minus x, minus the numerator function, x cubed, times the derivative of the denominator function. Well, that's just going to be -1. All right? So here, and then that's divided by 2 minus x squared. Okay, so let's do some simplifying and let me isolate y prime. Okay, so now I have dy dx. I'll be able to find that explicitly here. So let's see what we have in the numerator. So we have 6x squared. Okay, and this is going to be minus 3x cubed, and this is going to be plus x cubed. Okay, all over 2y times 2 minus x all squared. Okay, and even though I'm going to be inputting particular numbers here, let me simplify just a little more. So here we have 6x squared, -3 plus 1 minus 2x cubed over 2y times 2 minus x squared. Okay, could actually go further. I could factor out a 2 from the numerator and divide that out. But since all I need to do is evaluate y prime at a particular number, I'm not going to bother doing that. Okay, so what we're looking for here is y prime. Now notice how my derivative has both x's and y's. Okay, so I need to specify that I'm evaluating it at this point, and the notation that I've shown you to use is this bar, and then indicate as a subscript here the point at which you're evaluating that derivative. Okay, so I'm just going to stick in x equals 1, y equals -1. So here 6 times x squared is just going to be 6 minus 2 times 1 cubed is just going to be 2. 2 times y, so y is -1, so it's going to be -2 times, and here 2 minus 1 is 1 squared, so that's just going to be 1. So in the end, what are we left with? We're left with 4 over -2. So -2. Okay, so this represents the slope of the tangent. Okay, but what we're looking for is the slope of the normal, which is going to be perpendicular to that. Okay, so the negative reciprocal of -2 is just positive 1/2, and then I'm going to use this to find the equation of the line. Okay, so stick everything to y equals ms plus b, so it's got this slope. This should be positive 2. Okay, negative of a negative is a positive, sorry about that. So I'm just going to put everything to y equals mx plus b. So our y value is -1 equals, our slope is 1/2, our x value is 1, and then plus b. All right, so here I just have -1 minus 1/2, so that's just going to be -3 over 2. So our final answer here is going to be y equals 1/2 x minus 3 over 2. And there's our solution. Okay, so let's just recap. So first of all, recalling that a normal is just the line perpendicular to the tangent. So I'm still going to find the slope of the tangent line, and I do that by taking the derivative. In this case here, I used implicit differentiation, found the slope of the tangent, but since I was looking for the slope of the normal, I took the negative reciprocal and then used that with the given point to find the equation of the line I was looking for. Okay, that's it for this one.